Hello, welcome back to Geometric Virtual Learning Lesson 3 on similar shapes. In this presentation, we'll be talking about how to express ratios of area and volume of two similar shapes and to extend the expression of ratio of area and volume to three similar shapes. Ratio can be expressed from two corresponding units of measure from similar shapes. So this lesson is typical to what we talked about, scale factor. So let R represent expressing ratio of length or height. R squared is for area and surface area. R cubed is for volume and capacity. And the same dynamics works here. How to change from the right format, area to length, length to area. This is what you do. Volume to length and length to volume. And from volume to area, you go to length first, then to area, then area to volume. You go to length first by doing the operation specified, and then finally to volume. You cube it to get to volume. So I'm going to make use of these in my examples to explain what I mean by these arrows and the cube and the square root and so forth. We have triangles ABC and DEC are mathematically similar. We have to work out the ratio of the areas of the triangles ABC and DEC. So, the first thing you need to do, there are two ways of doing this. I'm going to do with two ways, and you pick the one that you want. First is the ratio method, because I'm going by ratio. Using ratio of lengths, so if you check what is corresponding. I have ratio of lengths that's corresponding. So it's 4:18. 4:18. And I can simplify this by dividing through by 2. So this is what I have for my ratio of length. Because we are talking about area, we need to change the ratio of length into ratio of area by squaring our ratio. So our ratio of area will now be 2 squared and 9 squared, which will be giving us 4:81. So the ratio of the triangles ABC and DEC, 4 for DEC, the smaller one, and 81 for the bigger one. So that's one way of doing it. The other way is using scale factor. So work out your scale factor from corresponding sides. 18 divided by 4 is 4.5. Now 4.5 means that the bigger one, ABC, is 4.5 times as big as the smaller one, DEC. So if you are doing expressing that as a ratio, ABC is 4.5 and DEC is 1, because this one is 4.5 times the original one. And in ratio, you're not supposed to leave it as decimal, so change it into, before we do that, this is ratio of length, square it to get to ratio of area. That's what you have, and we cannot leave it as a decimal, so we make it as a whole number. Multiply both sides by 100. Then you simplify it, divide by 25, you get back to the same answer. So it's a matter of choice. You can go by the expressing ratio from the onset, or use scale factor, knowing the scale factor and expressing the ratio from there. Now pause this video and see if you can work out this, express the ratio of their area. Okay, let's see. First is to express the ratio of their lengths or corresponding lengths. So the ratio of the base is 5:15. Simplify where possible. That is R. We want it as area, so we need to square it. So the answer will be 1:9. 1:9. Ratio of lengths to area and volume. Okay. We have two cylinders. They are mathematically similar, A and B. Height 12 for A, 18 for B. We are supposed to calculate the ratio of their surface area and the ratio of their volumes. So we use the height to work out R and change R into R squared to work out surface area. So ratio A and B is 12 to 18. Simplified by dividing by 6, 2:3. Always simplify where possible. Change R to R squared by squaring both sides. So you have 4:9. So ratio of surface area is 4:9. Now we want ratio of volume. Now we need to go back to ratio of R and change R into volume. So we need to cube R, and that will be 2 cube is 8, 3 cube is 27. So you know the difference, they are not the same. So everything has to be in the right format. R squared for area, R cubed for volume, and R for length or height. Now this is an exam style question. Two solid cones are mathematically similar. Cone A has a volume of 120 cm cube. Cone B has a volume of 90 cm cube, 960 cm cube. Work out the ratio of the surface area of cone A to the surface area of cone B. So we've been given measures in volume and we want answers in area. Okay, so you need to know the dynamics. First, we start with the ratio A and B, and everything is R cubed because it's expressed in volume. So what we have here is R cubed. Simplify where possible. So 120 divided by 120 is 1, 960 divided by 120 is 8. So have it simplified form, but it's still R cubed. I can't change, I need to get to surface area. So what I need to do is to get to R. To get to R, I need to find the cube root of R cubed. So cube root of 1 and cube root of 8. That gives me 1:2. So this is the ratio of length, or length if I should put it that way. Now I want to change ratio of length into ratio of area. So what I need to do here is to square both sides. That will give you, we square both sides rather, not square root. So we square 1 squared and 2 squared to get to our R squared. And that gives us 1:4. So we know A 1:4, B is 4, and A is 1. So the question is work out the area of cone A to the surface area of cone B. So that's what we've expressed. So just a quick glance through. You start with the volume, change volume ratio into length ratio, and change length ratio into square ratio. So that's the dynamics. Another exam style question where we have 3 similar shapes. A, B, C are similar. Shape A is 4 cm squared. Surface area of B is 25 cm squared. So the surface area of A is 4 cm. Surface area of B 25 cm. So that's one part of information. The ratio of the volume of shape B to volume of shape C is 27:64. Work out the ratio of height of shape A to the height of shape C. Give your answer in simplest form. So we are being moved from volume to area, and it's between among 3 different shapes. Let's go step by step. So we start with A and B, and we start with the area. So A is 4 and B is 25. Okay, we can't simplify, so we leave it like that. Now because we're going to talk about height, we need to change area into length or height format. We do that by squaring our ratios. So we have 2:5 for A and B. Now we have another information for B and C, but that information is for volume. Volume for B is 27, volume for C is 24, so that's R cubed. Now we need to also change that into length by finding the cube root, because we've already gotten A and B as length. We need to get B and C also as length so you can compare. You find the cube root of that. Cube of 27 is 3. cube root of 64 is 4. So let's line up A, B, and C so that you can see how to manipulate the numbers. We have A and B as 2 and 5, and we have the same B and C as 3 and 4. Let's put them down here. Now, the B must be the same. The same B is what you see compared with C, and the same B is compared with A. So it's like two things compared at different perspective. When you put a dog closer by an elephant, obviously the elephant is big. If you put an elephant next to a whale, definitely the elephant becomes smaller. That's what is happening here. But it's the same thing, animal that we're comparing across two different perspectives. So we need to make sure that we stabilize the B. One way of doing that is to find the LCM. The common number for 5 and 3 is 15. So we multiply this side by 15. That means all this side should be multiplied by 15. We multiply that side by 5. That means every side here should also be multiplied by 5. So here, multiply by 3, we get 6. Multiply by 5, we get 20. So now we know B is actually 15 compared to 6, and actually 15 compared to 20. The question wants us to compare A to C, the height. A to C, and this is the height format. A to C, so we pick A, which is 6. C is 20. So the ratio of A to C is 6 to 20, which can be simplified as 3 to 10 when you divide by 2. And that brings us to the end of lesson 3. Hope you've enjoyed it. Look forward to lesson 4, where we talk about 2 possible solutions to similar shape question. It's something that is popular in an exam, 2 possible solutions. Thank you very much for watching. Please share with your friends. Thank you.